Okay, so just a few minutes later than I anticipated, but I'm going to do a few videos here. I'm going to continue on from where we stopped, which is the hypothesis testing. We're about to start that, but I will put up videos from the start of statistics in case anyone is having issue or missed it. So I was saying yesterday that, you know, people make claims. So if we look at Ryanair, they make a claim that 93% of all their flights arrive on time. And we don't know whether or not we can believe that claim. So we could go maybe to Dublin Airport and we could take, you know, stand there and take a sample of as many planes as we possibly can and take note, do they arrive on time or not? If we did that, so in this section, someone went to Dublin Airport or, you know, wherever, they took a sample of 625 flights and they noticed that 535 of them were on time. So this claim has been made. We need to do a hypothesis test on it. We maybe went and did this, and then we're checking, right, well, from what we've done, is there sufficient evidence to reject the claim? So let's have a look here at the outline, and then I'll put up another video in a few minutes that goes into more detail. So as I said, we'll do it's called your null hypothesis. I don't know how to spell. And this is, I guess it'll have just one statistic in it. Like, you know, 93%. That'll be your one statistic in this situation. And then this is called your alternative hypothesis. So it's the alternative to that. And it'll be all other options. So this actually does make a difference, and I'll, like I said, I'll do a good few examples, maybe not today, but over the next few days, about looking at the claim. But we won't always put the claim here and the opposite here. We put in a one statistic here. In this situation, it'll be 93%, and all other. See, there's a reason it's called alternative. All other options is our H1 or alternative hypothesis. Then what we do is we do some maths here. We have options. What maths have you done over the last few days? Well, you've done a confidence interval. So we could do one of those. We could do a Z-score on a sample, if possible. And we could do something that we haven't looked at yet. It's called a p-value. Now, I don't want you to confuse it with p that we've been looking at over the last few days. It's just called a p-value, and you know, it's to do with percentages again, but it's nothing that we've done over the last few days. So I'm not even going to mention that here for the minute. If we're going to do one of these questions, we're either going to do it by a confidence interval or we're going to do it by a Z-score on a sample. And that formula is in your log tables, and this formula is stat plus or minus 1.96 times your standard error. And you can go to your log tables and find this one. And when we have the maths done, then we will look at whether we are going to reject the claim. It's our conclusion here. Do we reject it or fail to reject? So if, let's just say, the 93% falls outside my confidence interval, I will reject their claim. If it falls inside, I'll fail to reject their claim. So this can be a little bit just of a sticky thing. I'll never accept their claim. And the reason I can never accept their claim is because they've kind of said 93% of all Ryanair flights arrive on time. Unless I survey the whole population, all Ryanair flights, I can never really accept their claim. So we do our best with the statistics that we have. We look at our statistic and the all other options. We do some maths and we either reject their claim or we just fail to reject it. We will kind of give them the benefit of the doubt and say, yeah, okay, I see where you're coming from. From the sample that I've collected, I see where you got your 93%. I can, I can go with that. Now, but we never would say that. We just say we'll either reject their claim or, we don't reject that claim.